We're going to be learning about one-sided limits. That's today's lesson, one-sided limits. We're going to first start with the definition of one-sided limits. A one-sided limit is the calculated limit. It has to be a number, or it could be not existing, of a function from only one side of a graph. What this means is that we're going to be calculating it from the left side or from the right side. So when we were doing the examples last week and then this morning, or first thing on the do now, remember I was telling you to go from the left and right to see what that value is, okay? You're going to see when we actually do the formal definition, in order for a limit to exist, they have to be the same value, okay? You'll see that when we do the formal definition. Can I move down? Okay. Evelyn, I'll give this to you in a minute, okay? Elvis, go ahead. In math, we always have notation. So the notation to show the two types from the left and right side are as follows. Notation. Can you see that color? No? Now can we? Only one person. No? Yes? Thank you. The left side limit has a specific notation. It's very, very, very similar to the notation that we did last week. Like really, really, really similar. There's only one thing that's different. The limit as x approaches a from the left. This negative sign that is an exponent. This negative sign that is an exponent stands for the left side of that value. So this is very similar than what we did last week, very similar like what we did last week, but the only difference is this negative sign. This negative sign tells me I'm only looking at the left side of the graph from the left. Can you see that color? Okay, thanks. The right side limit is very similar. Instead of a negative sign, what do you think we're going to have? Positive. So it's the limit. As x approaches a from the right, this plus sign means that it's from the right. That plus sign means it's from the right. Of f of x is equal to c. Now for clarity, the reason that I used c instead of b is because it may not always be the same number. So in math, I have to make sure that I'm showing that it might not be the same number. It could be, it might not be. So that's why I use two different variables. Questions on that? And where's my other note? Oh, they're there. Am I moving too fast? Too slow? Just right? Okay. Okay. Now we get to the formal definition of a limit. In math, we cannot just say that a thing exists. We have to prove it exists. Okay? I don't know if in your geometry class you did proofs. Did you guys do proofs in geometry? No? Okay, forget it then. We have to prove that it's a limit. So we have the formal definition of a limit. So formal definition of a limit. So we're going to have words and we're going to have notation. We're going to have words and we're going to have notation. So in words, this is what the formal definition says. The formal definition of a limit says, for a limit to exist, meaning that it has a value, so it has an actual number. It's not, does not exist. Okay? It's an actual number. The left-hand limit and the right-hand limit, am I off screen yet? I'm assuming no. Must approach the same number. So in order for a limit to exist, the left side and the right side have to get to the same number. So we were doing that last week, and we did it in Do Now, but now we have a formal way to describe it. The left hand has to be equal to the right hand. They have to get to the same value. Evelyn, you need this? No? Okay. The last thing we have is notation, and then we'll get to the example. We'll do the do now and then an actual example. Are you ready? Christian? Ready? Okay. Elvis here. You're gonna need these. Okay. So we have notation. It's as follows. Because remember last week I said we don't like writing tons of words in math, so we create notations. So if the limit, right here. If the limit as x approaches a from the left of f of x is equal to b, and the limit as x approaches a from the right, oops, not times, plus, of f of x is equal to b, then the limit as x approaches a of f of x is equal to b. So all this is saying is if the left side and the right side are the same number, then the limit is that number. If the left side and the right side are the same number, then the limit is that number. And we kind of did that in the example on the do now, which I'll show you. Okay. And then the last thing. I want you to star this, highlight it, underline it, circle it, whatever you need to do to show that this is important in your notes. This is how you are going to explain in mathematical notation, okay? A lot of you skipped that on your exit ticket, which didn't get you your full points. You have to make sure you're explaining, okay? You will not get full credit. So you're going to use this for math notation. This is what you're going to use for math notation. The limit as x approaches a from the left of f of x is equal to the limit as x approaches a from the right of f of x. Does anybody know what these three dots mean? Have you ever seen this? And no? Yes? No? This means therefore. Remember in math we don't like writing tons of words? So here's a new symbol. Therefore, the limit as x approaches a of f of x is equal to b. So if I ask you to write an explanation in mathematical notation, it has to look like this to get full credit. When you're done writing that down, take out the do now. And I'm gonna show you how this works on the do now since we have the answers, okay? I wanna show you on the do now before we actually get to the example. Ready? Okay. Just hold on to it, Elvis. Okay. I'm gonna do, we're gonna do C and B. And I'm gonna do it sideways so you can see what's happening, okay? So B asked me to find the limit as x approaches -2, okay? So first thing I need to do is I need to look to the left. This is what we have been doing, right? We look to the left and we try to find that value. So this part right here is the limit as x approaches to -2 from the left because it's the left side of the graph. And when we found this, we found that this is -2. Are there any questions on that part? No questions? Are we sure? Okay. You good? Do I need to move it up? Some of you are straight. How's that? Is that better? Okay. Now we need to do the right side. So I'm going to go to the right. I get that number. So that's the limit as x approaches -2 from the right, which is -2. Are these two numbers the same? It's not a trick question. Are these two numbers the same? Yeah, they're equal. -2 is equal to -2. And that is why, mathematically, the limit was -2. Rafa, you good? Again, because this value is the same as this value. Left side is equal to the right side. The limit is negative 2. Okay? Now let's look at, what was 0? What was 0 next? Let's look at 0. If we go from the left side, we get to this point. So it's the limit as x approaches 0 from the left of f of x, gives me 0. When we do it from the right side, it gives me negative 1. The limit as x approaches 0 from the right of f of x is equal to negative 1. Oh, I cannot write today. Negative 1. Are these two numbers the same? You can't see. Why am I pointing? Are these two numbers the same? No. Negative 1 does not equal 0. So what's that mean? We don't know. Does not exist. Remember, they have to approach the same number. Otherwise, it's D and E. That's why mathematically, this one does not exist. I'm going to zoom in so you can see it. When you're done copying this down, take out the example sheet. When Jahira comes back. I am going to do the first 2 rows slower than the last 2 rows, okay? Because honestly, this is an honors class, and we gotta work at an honors pace. That's why I give you extra time to practice, okay? But if I go too fast, feel free to stop me. Okay. Jahira, here. I don't know where you left off on the notes. It's... Okay, so this one and this one. That's the do now. I wrote notes on the do now.
I write this one?
Yeah. And you got this? Mm-hmm. Okay. All right, so let's look at the example. I'm going to try to put both on screen. Okay. What does this arrow mean again in math? It's infinite. It goes on forever. So I'm going to extend that out to make it easier for me. So first thing I need to do is I need to find the limit as x approaches negative 10. What does this negative sign mean? To the left. From the left. So here is my line. And I'm going to go from the left. Remember, I go left to right until I get to an intersection, and then right to left when I get to an intersection. So from left to right, when I get to the intersection, I get negative 9. Any questions on that? Are we sure? Okay. Now I'm going to go from right to left until, again, I'm following that graph until I get to that intersection. I get negative 9. Questions so far? Are the left and right hand limit equal? Yes. Yes. So what does that make this? What does that make C? Negative 9. If these two are equal, Raphael, if these two are equal, you need to go get water? Then that means this is the same number. You don't have to calculate this again. That's why we're doing this, okay? Questions? All right, next one. I have negative 2, so I'm going to draw a line down negative 2. Am I off screen or can you see that? Nope, I'm off screen. So again, I'm going to move from the left to the right until I get to that intersection. That gives me negative 6. Then I'm going to move from the right to the left until I get to that intersection. That gives me negative 2. Are they equal? So what's the limit? Does not exist. I see some confused faces. Okay. So I'm looking at this like tealish line. Okay? I'm going to look from the left side because that's what this is right here. This little minus sign tells me left, the plus tells me to right. So I'm just looking at the left side of the graph. I'm going to go from the left to the right until I intersect the line that I created. And that is negative 6 because I'm looking for the y value, not the x value. I'm going to do the same for the right side. Go from the right to the left. That gives me negative 2. You can't see that, can you? Negative 2. So that is why this is negative 2. Because these two numbers are not equal, that means the limit doesn't exist. Questions? Okay, I'm going to do the next two really fast so that I can get through the explanations. I'm going to draw a line at 0. And please stop me. You can't see, can you? I'm going to draw a line at 0. I'm going to come from the left. And then I'm going to come from the right. From the left, I get negative 3. And from the right, I get negative 3. Are they the same number? Yeah. Yes, so what's that mean about the limit? Negative 3. So, negative 3, negative 3, negative 3. Questions? Did I go too fast? Are we sure? A lot of us are shaking our head no. Okay, so now I'm going to do 6. That's the next one, right? I'm going to the left. That's negative 6. I'm going to go from the right. That's negative 8. Are the numbers the same? No. So what's that mean about the limit? Does not exist. Questions? All right, the part 90% of you skipped is the explanation. I'm going to take this a little bit slower, okay? We are going to need to do I, and we're going to need to do F, right? So when I look at I, what you're looking at is you're looking at the values and the final answer. You're looking at the values and the final answer. Were these values the same? Yes. So the limit, the left side limit and the right side limit, can you see or no? No? Yes? Nobody's answering. Thank you. Approach the same value. Value. Did I spell something wrong? Right. Thanks. Thanks. Sorry. Therefore, the limit as x approaches, what are we, 0? Of f of x is equal to negative 3. That is what you should be writing. Not exactly, you don't have to write exactly that, but it has to be similar. This is vocabulary, so you need to use words. When we get to quarter 2, I'm not going to be giving you these hints. You should know to use words or symbols. Notation is symbols, okay? Question? Did you raise your hand? No, okay. All right, now the last one. You're going to be looking at these two things. What did we say about these two numbers? They're not the same. In math, what does that mean? What do we say instead of not the same? What? Huh? That's the final answer. What is it when they're the same? When two numbers are the same, what's the mathematical equal? So what's not the same? Does not equal. Wow, that was hard. So we're going to use these two notations. We're going to use this notation and this notation. And this is the only hint I'm giving you about this. Okay? This is the only hint I'm giving you about this. Because we're looking at these two things, the notation is there. You don't even have to memorize it. Okay? You just have to know what it means. So the limit, can everybody see? X approaches negative 2 from the left of f of x. Does not equal, because are they equal? No. The limit as x approaches negative 2 from the right of f of x. Therefore, the limit as x approaches negative 2 of f of x is what? What is it? What do we say when two things are not equal in limits? D and E. Questions? Did I go too fast? Yeah? Okay. If I went too fast and you have questions, when I come around, let me know, okay? Alright, flip over to the back. You're going to be working on this with your group for the remainder of class. I'm going to be checking one at random.